You've probably heard this before. Energy never dies. You don't disappear. You just transform. It's comforting, almost poetic, and it leads to a quiet, seductive assumption that somehow you persist, that when your body stops, your energy continues in a meaningful way, carrying you forward into the universe. But here's the uncomfortable truth. The laws of physics don't care about comfort. And if Richard Feynman were sitting here smiling that mischievous smile, he'd say something slightly annoying and devastatingly precise. Yes, energy is conserved, but you are not. Today, we're going to answer a question that sounds spiritual but is brutally physical. Where does your energy actually go? And why the real answer is far more beautiful and far more tragic than the myth. When most people hear energy, they imagine something mystical, a glowing essence, a spark, a soul-adjacent substance. But physics has a much less romantic definition. Energy is not a thing. It's not a substance. It's not a fluid sloshing around inside you. Energy is a number, a bookkeeping system, a way the universe keeps track of motion, heat, vibration, chemical bonds, and fields. Feynman once described energy like this. It is an abstract idea, a conserved quantity, something we calculate, not something we can see already. That should make you uneasy. Because if energy is just a number, then whatever you are, you're not the number. You're the pattern the number temporarily supports. Let me give you the first crucial analogy. You are not a battery storing energy. You are a fire. A flame doesn't contain energy. It processes energy. The candle flame exists only because wax molecules break apart. Oxygen rearranges electrons. Heat flows outward. The moment that process stops, there is no flame left behind, no flame energy waiting to go somewhere, just warm air and scattered molecules. Life works the same way. Your body is not a container. It's a process, a wildly complex chemical fire that burns slowly for decades. And when that fire stops, there is no U-shaped energy packet that floats away. There is only heat, motion, and randomness. Let's be fair. The first law of thermodynamics says energy cannot be created or destroyed. So technically, yes. Every joule of energy that once powered your thoughts, muscles, and heartbeat continues to exist. But here's the catch that everyone skips. The law says nothing about usefulness, nothing about organization, nothing about meaning. Energy can be conserved while everything that mattered about it is lost. Which brings us to the second law. The second law of thermodynamics is the real villain of this story. It says, in an isolated system, entropy always increases. Entropy is often explained as disorder, but that's sloppy. A better definition is energy spreads out. Differences disappear. Hot things cool. Concentrated energy disperses. Useful energy becomes useless heat. Life exists by fighting this law locally, by dumping entropy into the environment. But eventually, the bill comes due. An ice cube melts in a warm room. Energy flows into it. The total energy is conserved. But can you ever get the ice cube back without doing extra work? No, because the energy is now spread out among trillions of vibrating molecules. The energy didn't vanish, but the structure did. That's the story of death in one image. At the microscopic level, nothing dramatic happens when you die. Atoms keep vibrating. Electrons keep buzzing. Thermal motion continues. Physics doesn't notice your death. But at the macroscopic level, the pattern collapses. Your memories, personality, identity, those were extremely specific arrangements of matter and energy, and the universe is very bad at keeping track of specifics. Imagine a deck of cards arranged perfectly by suit and number. That order is rare. Now shuffle it. The cards still exist. The energy of your hands still exists, but the pattern is gone. Could the deck randomly return to perfect order? In theory, yes. In practice, not before the heat death of the universe. Your body is that deck, except with 1,028 particles. So let's answer the question directly. When you die, your energy goes into heat, warming the surrounding air, into chemical energy, feeding microbes and plants, into motion as molecules drift and collide, eventually into infrared radiation leaking into space. It doesn't go together. It doesn't go anywhere meaningful. It dissolves, not spiritually, statistically. At this point, people protest. But life is different. But consciousness. But biology. Feynman would grin and say, biology is physics. Life doesn't escape thermodynamics. It temporarily exploits it. You are not a closed system. You survive by stealing order from food and sunlight and dumping chaos into the world. Death is simply when the theft stops. A sandcastle doesn't violate the laws of erosion. It delays them. Wave after wave hits. Eventually, the structure dissolves back into sand. The sand didn't disappear, but the castle did. You are a sandcastle made of atoms, an outrageously intricate one. Here's where most explanations fail. They stop at decay, but Feynman never stopped there, because the real miracle isn't that energy lasts forever. It's that patterns ever form at all, for a brief moment in cosmic time. The universe arranged matter in a way that could ask questions, feel wonder, understand its own laws. That's not meaningless. That's astonishing. You are not important because you last. You are important because you happened, because for a tiny window of entropy-defying rebellion, the universe knew itself through you. Your energy doesn't need to carry your identity forward. It already did its job. So where does your energy go? Everywhere, and nowhere that remembers you. And that's okay, because permanence was never the point. The point was that atoms, obeying blind, indifferent laws, briefly assembled into something that could ask, where does my energy go? Let me ask you something. If nothing about you lasts forever, does that make this moment meaningless or infinitely precious? Tell me what you think.